Hey,
Hey,
we are here.
hey there, hi there, hello there.
We're here at least on one of our channels tonight. We're not. We're having some trouble with Facebook. Hasn't been the first time. Won't be the last. Anyway, welcome back everybody to the Sunday Night Astronomy Show. And I just need to get my notes going here because I had them open as well. Here, let's get my welcome screen up. Whew. Okay. I don't like it when things don't come together very well, but anyway. Hello everyone, and welcome to our Sunday night offering of astronomy outreach, the Sunday Night Astronomy Show.
Hey!
Yay! Okay. My name is Chris Kerwin. I'm the creator of the social media channels known as Astronomy by the Bay. I am an amateur astronomer and a member of the Royal Astronomical Society of Canada. And first of all, I'd like to welcome back our two regular co-hosts, our fellow RAS member, Mr. Mike Powell from the PFO Observatory here in St. John. Welcome, Mike.
Puffo.
And I'd like to welcome back our other regular co-host and fellow RAS member, Mr. Paul Owen from the beautiful Moon Shadow Observatory in Hampton. Or beautiful Hampton. Yeah, there we go.
Yeah,
I got it.
yeah, it's a
I
nice
think I got it.
observatory.
Yeah,
Yeah,
you got it.
yeah,
Yeah,
that's it. There.
yeah. You got it.
Okay.
Yeah.
Welcome everybody to YouTube. Okay, on tonight's episode of the Sunday Night Astronomy Show, the astronomy world was overwhelmed with satisfaction with the recent first release of the spectacular images from the James Webb Space Telescope. But what does all that data mean for astronomers and astrophysicists? Well, there have been a lot of explanations offered and a lot of information offered to help explain the images. One of the best articles I've seen from a website so far is in Australia. So tonight, in our discussion segment, I'm going to take a close look at that article that I looked at, and we're going to review what it says about SMAX 0723. That's the one we'll take a look at tonight. Also tonight, Mike will give us another method to save astronomy dollars in his Mike Guyver segment, and Bino Bud has promised to return with another timely binocular target of the week. And Paul will be delivering another interesting episode of Rosanna's Fun Facts. And he has another idea to share in his astrophotography tip of the week. Hey!
Yay! Oh, now, yay!
Hey, there we go.
Oh,
I'll be offering a quick view of what to look for in our sky this week, and I'll have all of your wonderful photo submissions to share as well, so another pretty busy show. So this is a family-friendly interactive live broadcast, so for those of you joining us from our YouTube channel, we're happy to try and answer all of your astronomy questions in real time as well. I'm trying to be serious here, and I just can't be serious. Doesn't matter with these guys, you just can't be
no,
serious. Huh?
stop it.
Doesn't work. Doesn't work. Okay. Anyway, we are happy to try and answer all of your astronomy questions in real time as well. And of course, we'd like to welcome all those who have been joining us through the local Rogers TV network. Thank you for support. Appreciate it. So let's get started, guys, I guess, with tonight's program and a closer look at the wonders of the first Webb telescope images. And I just need a second to make sure that people understand that we are where we are tonight. Oh, let's go here. Okay. What I wanted to do was bring up a site, so I got to share my page. And I found this really cool website. This one, yep. And it comes from abc.net.au. And so it's out of Australia, but they gave a great description, I thought, of what was going on with the Webb telescope and some of the images that it had released, and a bit of a description around them. So I'm going to take a little bit of a walk, maybe just through, we'll see how far we can get because we're starting a little bit late tonight, of course, and we're going to look at maybe SMAX 0723. So I just want to walk down through the page. Guys, you can help me out along the way here. So the James Webb Telescope promised to give us a mind-blowing view of the universe, and has it ever? This week, the biggest and most powerful space telescope beamed its first snapshots of the cosmos back to Earth. Now, the four images offer the most detailed glimpses of the universe we've ever seen. It's a visual feast of the early universe, cosmic cliffs, dying stars, and battling galaxies. Now, let's take a dive in and take a look at this one at least, the SMAX 0723, which was the most amazing shot, I think any of us have ever seen. We just didn't expect this type of detail for sure. Now, our first step is a deep dive back in time, focusing on a large galaxy cluster known as SMACS, or SMACS 0723, in the constellation of Valens. Now, packed into this tiny sliver of the universe are thousands of galaxies of all shapes. We had a button here to the full screen. There we go. And sizes and ages, lit up in a kaleidoscope of colors that correspond to different wavelengths of infrared light. Now, the striking image is much sharper and contains more detail than the Hubble image of the same patch of sky, says Carl Glazebrook of Swinburne University. Now, there's so much physics and astrophysics going on, it's hard to know where to start, he says. And that's true. But we would not be able to see such detail in this image without the help of SMACS 0723, which is that big cluster in the center. Now, the mass of the cluster warps space and stretches light from more distant and older galaxies from the early universe as it travels towards us. Think of this image as a 3D journey through space and time. Now, as the universe expands, it stretches the wavelengths of light coming from stars and galaxies farther away, so they appear redder in infrared light, and objects closer to us appear much lighter. So that's kind of like a train passing you by. It has a high-pitched sound, and then as it drifts away from you, it's a low-pitched sound. That's because of sound waves. We look at the same thing with light. In the foreground now, you can see bright, spiky stars from our own Milky Way. Now, these are the spiky ones. We thought might have been able to get cleaned up, but the spikes you see are caused by diffraction of light in the telescope's mirror, which is made up of 18 smaller hexagonal-shaped mirrors. And then there are the other galaxies farther away, like this spiral galaxy, out towards the edge of the image. Look, there's tons of galaxies in here. The group of galaxies that makes up SMACS 0723 is even more distant. Now, the light from these galaxies has taken 4.6 billion years to reach us. Now, to put that in perspective, this is how the cluster appeared when our solar system was just starting to form. And the cluster has many large fuzzy galaxies like this one, which is right at its center. And from there, the giant red arcs stretching around the center of these blobs are much more distant galaxies that have been magnified by the cluster. So it's called gravitational lensing. It's something they use quite often now. The galaxies like the spiral galaxy in the top right has been stretched by the gravity of this large cluster of galaxies. And from there, if you look closely, you'll see the same galaxy repeated on the other parts of the image, like over here in the bottom left, because of the way the light bends around SMACS 0723 on its way to us. If we zoom in even further, things get really interesting. So near the stretched galaxy is what looks like a pearl necklace, right there. And the beads are probably star clusters in a small compact galaxy, Professor Glazebrook says. Zoom in even further, and you can see more detail in the necklace. Amazing. We're seeing a wide range of colors we haven't seen before in the early universe, Professor Glazebrook says. Now, the oldest galaxies, just specks of red, appear as they did just a few million years after the Big Bang, and they may actually no longer even exist. But the light from their demise hasn't reached us yet, or the no light, I'll say, from their demise. The color and analysis of the wavelengths of molecules detected in light coming from this faint dot suggests that this is about 13.1 billion years old. Now, that's just about 700 million years after the Big Bang, but there may be galaxies that are even older in this image. And that's what I'm going to talk about as far as SMACS 0723. They do get into a bit longer discussion here about the cosmic cliffs, the Carina Nebula, and the other things. So I do suggest that you go to that page, take a look. It's called abc.net, abcnews.net, and .au, and they have a whole article listed in there. Now, I just wanted to see if I could bring up a picture. I think I've got it here somewhere. This is the 30 megabyte picture that was released. There's actually one of the Carina Nebula is actually 28 or 180 megabytes. Sorry. So if we zoom in here a bit, you can see what we're talking about. It just goes on and on and on, right? There's just so much to be revealed there. I mean, this single image will keep astronomers and astrophysicists busy for a long time, I assume. It's too bad about the spikes, Mike. You're right. I mean, they look pretty, but they do kind of distort those parts of the image. But we've got every type of galaxy in here you could imagine: spirals, edge-on, ellipticals, large combinations of galaxies, collisions between galaxies. Look at the bending of light here, and there especially. Right. But even if you dig even deeper down in here, you're really looking at some fainter galaxies, right? There's just so much in this image. I mean, that's only the size of a grain of sand held at the end of your arm. So it's just unbelievable how much information is available in just that one image. So to me, it's like you have to congratulate these people for the hard work and the 20 years of effort that it took them to get to this point. And I can only imagine, I can't even imagine, I guess none of us really can, what's to come, right? They did release an image, Mike, we talked about Jupiter in infrared. Yeah. And it wasn't quite as sharp as what we were used to seeing, with visually with Jupiter, but there has to be information in there that they're gathering for sure.
Oh, absolutely.
But because we're in the spectrum of infrared here, we're getting light from galaxies that are so far away, we can't really use our visual perception or visual field, I guess I'll call it, to see this. But this is being captured in infrared or just the near infrared anyway. But yeah, there's going to be detail in here that they're going to, and just to have that all that gravitational lensing going on around that big cluster, it's just amazing. So congratulations to the team for sure for what they've done in their efforts, and I just can't wait for more of the stuff to come. I know we're getting into a little bit late, so I'm probably going to stop it there, guys. Might be a good idea.
All right.
See if I can get this out of here. I think it's F11. Anyway, there it's. Oh, let me make sure I don't hang up on you. That'll be something I do tonight.
Well, we haven't done that in a while.
No, we haven't. No, we haven't.
That's
You're
true.
right. There we go. Hey, there's the X. That's what I wanted. There it is. abc.net.au. That's what you want to copy down. And there's a whole pile of other, as I mentioned down in here, there's a lot more going on. So lots there to take a look at.
It is crazy.
It's a big deal,
Yeah, that much detail. It's just unbelievable.
Yeah.
Yeah.
If I was an astrophysicist or an astronomer, I'd just be jumping out of my skin. Like all I want to do is look at that photo all the time. And I think there are people that have blown it up now, put it up in their walls, and all kinds of neat stuff. But
yeah,
it is really, we are really turning a page into understanding the universe, I think, with these images for sure.
You can zoom in and it never ends. It just keeps going and going and going.
The one I downloaded for the Carina Nebula was 180 megabytes. I mean, the detail on that image with 180 megabytes just has to be crazy, right? And this one was only 30 megabytes. I've looked for a higher res image of SMAX. It's probably out there, but I haven't found it yet. But it would be nice to get into that field even deeper and take a look. But it's a pretty picture.
Well, they put up that cool shot where they compared Hubble's shot of that area with the new James Webb shot of that area, and there's just no comparison.
No.
Yeah.
Yeah. I mean, we were amazed with what Hubble was able to release.
Exactly. And then this comes out and it's like, wow.
But think about how old the Hubble technology is too, and the fact that it's a broadband type of camera that's on there. It's not infrared. It's a different technology.
Yeah.
But it's also when was Hubble go up? 86.
Yeah,
I think it was that. Yeah.
So that's so that technology that's up in space, that the mechanics that are up there now in those cameras are, they're quite old.
Yeah. Webb has a 20-foot mirror and Hubble has an 8-foot mirror. 10 foot
well, just not getting the light gathering alone, but
No, it's impressive. Like again, we were so impressed with. I know still with Hubble images, they're still amazing. But we'll all be looking for the Webb ones now. All of us.
I think digital cameras were just coming out when Hubble went up.
Yeah, true.
Yeah, look at digital cameras today, right?
Yeah,
Yeah.
yeah, that's right.
Yeah.
Okay,
Crazy.
well, I mean, we're all looking forward to what's coming, so let's hope for the best for sure. I think
Well,
somebody had
they
mentioned that
they
they're going to
have
release
enough.
more next week.
They have enough propellant on that for 20 years to
Mm.
keep that moving and doing what it needs to do.
Oh, yeah.
So
Somebody sent me a link on that James Webb had put out, and it's a complete presentation, a PowerPoint presentation on Webb. It's got about 40 slides. It gives the notes and everything with it. So I might try to come back sometime through the week and try to offer that out as a talk here on YouTube and Facebook. But it was I went through it today. It was really, really detailed. Like, it really gave a lot of nice information, but not too detailed. You know, something that the average person can pick up on easy. So, but
yeah.
they're really putting that information out there um, with Webb. You know, and hopefully they'll do that with other missions as well. But they're really revealing why we're doing what we're doing with it, and you know how it's working. So it's great. Good
Yeah,
publicity.
no,
Yeah,
exciting times.
yeah, absolutely. Okay, let's go from there then to Bino Bud.
I know, but there we go.
Awesome.
Binocular target of the week this week by Bud.
Bye-bye.
Eddie's roller coaster.
Yes, sir.
Yeehaw! So, invented by British astronomer Eddie Carpenter, known as Eddie's coaster, the meandering, double-dipping wave of faint stars lies about 3 degrees northeast of Gamma Cassiopeia at the center of the W. Eddie's coaster includes more than a dozen stars spanning 2.7 degrees, so it's quite an object. The chance alignment reminded Carpenter of an amusement park roller coaster, thus led to the asterism's name. And how do I find it in the sky? Well, wait till it's dark, around 11:30. Orient yourself at 35 degrees northeast, and you look up and you see the W Cassiopeia. And basically, it's right in this area right here. If you come up from the center of the W, you're going to hit the end of the roller coaster. It sits right here. So you can't miss it. Find the center of the W and come straight up, and you will hit the roller coaster. A little closer look again. There's the 2 bright stars in the center of the W. Come straight up, and you're going to hit the roller coaster. You can't miss it. And it does stand out, because here's a photograph of it. And this is Eddie Carpenter, the guy that named it. So
look at that.
I thought I'd throw that in there. Wow, double. See, I'm seeing double. 10 by 50 binoculars.
Well, you get 2 binos, right? So
There you go. Yeah,
you
one on each
refocus.
side.
You got to refocus.
Just not collimated, I guess.
Yeah.
I must have dropped them. That's what happened. Gee, come up from that center star in the W and look, there it is. It's just a perfect wave. And it actually, if you wanted to continue, it goes all the way down to here.
Wow. Yeah.
So it's quite a size. Compared to the full moon, well, there's a full moon. Each hump is at least a full moon. So you're looking at 3, maybe 4 full moons in length. So it's really good size. And it's real easy to spot. And it's real easy to look at. Like, you'll notice it when you fire your binoculars up there. And then and that's Binocular Target of the Week by Bono Bob.
Awesome.
All right.
Thanks, Mike. Another great one to try. W's up there really, you know, what's up there all year, right? Circumpolar.
Yeah.
But nice time of year to be out there looking for any of that stuff. So awesome. Thank you. Okay. How about we go to an Astro Tip of the Week next?
All right. All right. Let me just see if I can make it. So,
Tony Yellow Snares.
what am I looking for? I can never remember what I'm looking for.
Astro Tip of the Week.
Yeah, no, I know that. But
I think when his shirt fades in and out when he's searching, though, that's pretty cool.
That's cool.
there we go. Okay. All right. I'm going to share a moi screen, or I'm going to try to anyway. Your entire screen. There we go. Okay. So I had a question this week on my Facebook page where I post some photographs, and the question is how do you get the moon to look so big in a photograph? And I thought to myself, you know what? That's probably something that a lot of people don't know how to do. And I thought, you know what? I'll talk about that this week because it's very simple to do, but it requires a little bit of planning and a little bit of know-how with your camera, but nothing outrageously crazy. I'm going to show you how to do it. So what you're looking at right here, I'm just going to shrink this down. I'm going to hopefully be able to do this. So this photograph you see right here, that full moon, looks absolutely giant, right? And the reason being is because it was how far I was away from what is in front of it, and that's the whole trick to doing that kind of a moon. Now, I'm going to show you a couple of examples of what I mean when you take a picture of a moon, and this is where a lot of people, when they shoot a picture of the moon in the background, this is what they see. They see this little tiny dot, and they see these great big giant trees. Well, there's this thing in photography called the Ponzo Effect, and it's in when the moon rises over the horizon first, it looks so big, but as it gets higher in the sky, it looks smaller. But the only thing that's changed is its perspective to you as a viewer to where it is in the sky. When it's up higher in the sky, it has no scale. So there's no relation to how big it really is or how small it really is. But whether it's on the horizon or whether it's up overhead, it's the same size, but we perceive it differently. So if you look at this image here, the first thing you can see is that kind of cool little moon in the belt of Venus, and then it reflects in the water. So it's a pretty picture, but it doesn't give you that great big, where's that huge moon look? And how do you do that? Well, it's actually will be done with the opposite way that this one was done. This was done with a cell phone camera. Just took a picture with a cell phone, took the picture, and it's a wide angle camera. So, for this particular shot, I didn't zoom in. So the reason that it looks so small and puny is because A, my foreground is really close to me, and B, the moon is far, far away. But the thing that does never change is the size of the moon. What does change is what's in front of you. So let's have a look at another image. That's pretty much the same one. So here, for example, is from my front yard, and I took a picture of the Moon and Venus conjunction right here. This was quite a little while ago. But look how tiny the Moon and Venus are in that image compared to the houses. It looks like, it's something that could drop right in the chimney and you could, take it out and have it for dinner. It's how small it looks, right? So what I wanted to show you is this kind of effect is what you're trying to achieve. When you want those trees to look really tiny and that moon to look really big. And there's another example I think I have that I want to show you. This one right here. And here's a perfect example of it. Now, how this image was shot was this house was actually probably close to, I'm going to say about a mile away from me across the river. And instead of using a wide angle lens, I used a telephoto lens so I could get that house. But if you really stop and think about it for a minute, that house, if it had been in front of me, would have been like a gazillion times larger than the moon because the perspective of the house was right in front of me, right? So the further I can get that house off into the distance, the smaller it gets to my perspective, but the moon's perspective does not change. So the smaller that we can make our foreground target, the larger the moon is going to appear in front of it. And that's the whole, that Ponzo effect, is you need to have your foreground objects very, very far away. Use a wide angle lens so you can get at least a reasonable image quality of that far away target. And have the moon as close to the horizon or as close to, if you're doing it in a city for a cityscape, as close to the building that you want to see it above when you shoot that picture. Because the more distance you get between it, you're going to lose all the effect of it anyway. So that would be it. Now, the other part of this is the planning part. And what I mean by that is when you're actually going to go out and you're actually going to think about what do I want in the foreground that would be really cool in front of the moon. And it could be a countryscape like this one. It could be a cityscape, because the beautiful thing about the moon is, regardless of where you are, light pollution is not going to affect the shot. So because the moon, when it rises up very low on the horizon, is going to give you all that glorious color. Sometimes that little distortion, all the cool things that the moon will do, trying to break through the atmosphere. So whatever it is you want to put in front of it, just make sure it's extremely far away. For example, if you see somebody who's standing in front of on top of a hill with their hands up and they look like they're going to carry the moon, it's because somebody who's shooting that picture is very, very far away from them and where they are standing in relation to the moon. So that's really what it's all about, is in being in relation. Now, in terms of, I want to show one more, and I don't know where they go. Is it here? I keep losing my, oh, there it is. So I'm just about done here, but I just want to cover this other page. So how to do it. I just want to have this screenshot if you wanted to do it. And then I'm going to show one image of an actor from another local amateur astronomer took a picture based on what I'm going to tell you here. So how do you do it? You have the moon just rising over the foreground target. Have your foreground target as far away from you as possible. Use a telephoto lens in order to keep clarity, resolution, because even if you have to blow it up, and be able to avoid a too small a target and moon in your image. So if you use a wide angle lens, it might be a scale to each other, but it might be so far away by the time you blow it up, you'll lose all the resolution anyway. And plan in advance by scouting your site. Now, I want to show you one more image that Trudy Allman shot. And this shot will only happen once, and it might even be once a year, maybe a couple times a year if you're lucky, but you have to be able to plan to get it. And she shot this moon coming up over the ocean at Split Rock, which is in out by Garnet Settlement in New Brunswick, right on the Bay of Fundy. And in this particular shot, you can get the sun coming up here and you can get the moon coming up here. But you have to plan in advance, knowing when is the moon going to be full, when is it going to come up in that particular spot. You've only got a very specific angle you can actually achieve to get a shot like this. And then be there when it's there. And then at the same time, cross your fingers that it's clear sky. So it's a lot of elements that are in play here to take a shot like this. But Trudy's done this one a few times with sunrises and moonrises, and an absolutely stunning image, but well planned and using that same kind of effect that we were just talking about. Being able to zoom in and find something that is going to be in relation to the size of the moon to make it look really, really big. And that is my astro tip of the week.
Awesome. Thanks, Paul.
Okay.
Great stuff.
Yeah. That's why I bought a telephoto lens.
Make that the new one. Yay!
Yay. And cell phones don't always work. I mean, they do give you a tiny image sometimes, but they've got to come up with better zoom on a lot of the cell phones. I know some of them are beginning.
Well, they work really, really well now.
Yeah. Okay, let's go from there to WhatsApp talk then. Maybe I'll do a quick WhatsApp. It's not very long because there wasn't a whole lot of stuff I could find for this week, but just bear with me. I'll see if I can get it on the go here. Show you this file here. Oh, I don't want to bring it up here. I want to bring it up here. And first of all, I'm going to share my screen too. Hang on. Oh, hang on. Love being live, huh?
Yeah.
The joys of being live.
Yeah, baby. Yeah.
Yeah, baby. Okay. From beginning. Here we go. Okay. Hey, what's up?
There we go.
Yeah.
Okay. This week, let's take a quick look at what's going on. Tomorrow now, July 18th, Moon and Jupiter rise at midnight. So look to the east tomorrow evening at midnight. I could actually probably say this was Tuesday, early Tuesday morning, but it's midnight for us. For our waning gibbous moon, the moon is now waning. Of course, we're past full, long past full. And it rises just after the giant planet Jupiter. Now, both are ideally binocular targets, ideal binocular targets, with 4 of Jupiter's 79 moons visible at that time. In fact, they should both fit together in the same field of view of binoculars. I think they're only about 1.5 degrees or 2 degrees apart. So you should be able to get the nice waning moon and Jupiter and a few of moon all together in binoculars or small telescope. So nice target. Also, same thing. Same thing. I guess just after midnight on tomorrow evening into Tuesday, Not only will you be able to view the 4 Galilean moons, but Jupiter's Great Red Spot, an anticyclone large enough to swallow Earth, will also be clearly visible in small telescopes that evening. The spot will be front and center shortly after midnight. Midnight.
Midnight.
Midnight.
Midnight. That's a new. We'll start a new word.
Yeah. I
Delphinius.
turned off spell check, and I probably shouldn't have. Yeah, like Delphinius. Yeah.
Like Delphinius.
Okay, on Wednesday, we've got our third quarter moon. Early Wednesday morning, look to the east once again for the third quarter moon. The moon is now prominent in our early morning sky and visits the remaining morning planets over the next few days. Follow along that line that separates day and night in the moon, the terminator line, to get the best views. And the third quarter arrives at actually 11:18 Atlantic time. So it's later in the morning, but we'll call it third quarter moon anyway. On Thursday, our moon greets Mars. Look to the east again Thursday morning as a crescent moon greets reddish Mars. The two will be about 3 degrees apart, easily fitting together in the same field of view of binoculars. So you get an opportunity here a couple of times to get the moon and another planet in your field of view. If you are early enough, you should be able to pick up the beautiful Pleiades star cluster in Taurus before sunrise. Remember that one? The Pleiades cluster? That's our winter time.
Yeah.
Yeah.
Too soon.
Yeah. Well, it's only up for a very short time when it's daytime and it's gone. So, why is it called an anticyclone? Not just a cyclone. I guess it's because it rotates counterclockwise. Or not. I believe that's why they call it an anticyclone.
Do they have anti-tornadoes?
I don't know. I'm not sure. They have antipasta.
Hurricanes and hurricanes?
Friday, June 2nd, the moon and Uranus. The planet Uranus can be difficult to spot. On Friday morning, it will be much easier. In fact, it will be less than a finger width away from the moon, actually 0.1 of a degree. So that's pretty close. Uranus will appear as a hazy green star or a soft ball. It's not possible to view any features, if there were any, from Earth, but it is still an accomplishment to say that you've seen it together with the moon in binoculars. So you want to never have a look at Uranus. The way to find it is to find the moon, and that'll guide you to it on Friday. I always like to post this up. Lisa's Lookup, Astronomy and More. Lisa Fanning puts up this great chart every month. You can find her at Ruby Moonbeams on Instagram, Twitter, and Facebook. She lists the events, she lists the dates, and she lists the peak times for that event and what you need to view it with, naked eye, binoculars, or telescope. So follow her at Ruby Moonbeams on Instagram, Twitter, and Facebook, and we'd like to wish her a very happy first anniversary as well. Lisa.
There you go.
Yay.
Yay for Lisa. And another note, July the 17th to August 24th. I should put this one in first. Anyway, although we're still almost 4 weeks from its peak, the Perseid meteor shower has begun. Now, it's known widely as the best meteor shower of the year, not only because of its good rate of meteors, not the biggest one, but it is, of course, because of the fact that it's due to the warmer summer nights. So this year, unfortunately, though, a bright moon will wash out all but the best meteors during the peak dates. But the show takes some time to take place, so as our moon moves closer to new phase coming up now, for the next week or so, be on the lookout for some of them, especially around midnight. So when Perseus is up nice and high. So the Perseid, there's a Perseid meteor there, but Perseus is actually down here behind this tree. But you don't have to be looking right there. They can come from any direction, really. There's Andromeda. There's the big W shape of Cassiopeia Mike was talking about earlier. So
look, there's a roller coaster right where that meteor is.
It is too. Yeah, look at that. So it's pretty easy to spot Cassiopeia. So just below that is Perseus, and that's supposed to be the radiant, or the point where they all seem to be coming from. But again, you can turn your back to it or look straight up. It doesn't really matter. They're going to be coming from all directions because they don't all come in one straight line. But so that's a Perseid meteor shower starting July 17th, ending on the 24th of August. There's lots of time. And it'll just get better as we get closer. So best time, really, about a week from now, new moon, good time to be going out. And the St. John Astronomy Club and Royal Astronomical Society of Canada, the New Brunswick chapter, we're all members of that. And here's our July-August 22 calendar, so all the things that are happening for July and August, up till the 13th of August anyway. Up here at the top, we do list the Jupiter events because there are usually a number of them happening. If you see the number 1, that's moon Io, then 2 is Europa, 3 is Ganymede, 4 is Callisto. Then EC means that it's eclipse, TR means it's a transit, so you can go down to one of the examples here. There's a SH, which is shadow ingress, so it's moving into the shadow, Io, at 2413. So he lists a number of these right through it. There's the Mount Carlton Star Party coming up on the 30th.
July 29th and 30th.
29th to 30th.
If you're in New Brunswick, come on up to Mount Carlton, the best skies in the province.
It's true enough.
Big
Best
Star
skies
Party
in the
going on.
Yeah. And this is one I was going to announce soon, August the 5th. Irving Nature Park is the date that has been selected now for public observing within the Irving Nature Park, the first urban Stark Park in Canada.
And August 21st, is it? Head down to St. Martin's?
Yeah. July 21st.
July 21st? Yeah, Old Home Week.
Old Home Week, yeah, next week.
Next week, go down there. It's a fun time.
And another free evening of public observing. So,
yeah,
lots to look forward to. So, there's a few things that are happening this week. Anyway, there you go.
That's a comparison if I ever seen one.
Okay, we'll end the slideshow for there. And
is that Charlie the Talking Horse?
Yeah, that's him. Okay, we're going to move right on to a Mike Guyver. Next.
Oh, Mike Guyver. All right. MacGyver tip of the week. This one's going to be a little bit different. It's not necessarily going to save you money, but it's definitely going to save you some frustration. How's that? Ever run into cable management issues? With anybody that's got any type of astrophotography gear, you are definitely running into cable management issues. You got stuff hanging everywhere. And with that mount flinging around, you're bound to snag a cable. Well, guess what? No worries. NASA developed Velcro, or what you call a hook and loop. And it is an astronomer's best friend. It can be used for anything. You name it, you can find a use for Velcro. It'll secure all your telescope wires into a nice, neat bundle. You can secure your dew shields with it. You can secure dew straps with it. You can even put finder scopes on with just Velcro. You can hang flashlights from your tripod legs or anything you want like that. You can actually use it to secure your Solter fillers, and the list goes on and on and on. It's endless what Velcro can do for you. And it comes in numerous different types. You can buy it as a roll with the hook on one side and loop on the other. You can buy it as 2 strips that are basically sticky. You can peel and stick them on with the loop on one side and the hook on the other. You can even buy just little tabs if you want to in boxes. I mean, it's endless what you can do with Velcro. And I'll tell you right now, it's an astronomer's dream. I swear I have an astronomy trailer and the wall is just plastered with Velcro. I can throw a ball and it will stick just about anywhere on the wall. I mean, look at the uses here. There is a solar filter and it's being held on extra with Velcro so it doesn't fall off if it gets knocked over. There's a hand pad. You basically put a strip on the back and a strip on the leg and go snap and your hand pad doesn't move. Here is a dew shield. And again, it's just helping being secured on with a couple of Velcro tabs. And even the astronomy manufacturers themselves or the equipment manufacturers themselves like Celestron, this is a hand pad holder. And guess what? It's made of a strap and Velcro. So if you got an imagination, you can use Velcro. And you got that cable disaster like this, no worries. Averted. Look at that. Velcro. And I got one wire hanging down. It works no matter what you do. Velcro is the best thing since sliced bread. So if nothing else you buy is an accessory for your telescopes, get your hands on some Velcro. That's all I can say. You'll never regret it. And that's my MacGyver tip of the week.
True. Very true. AA batteries or the 2032 batteries, the little 2032 batteries at the dollar store, 3 to pack for $1. Pick up half a dozen packs, throw them because you can pass them out to people who don't have them, and packs of Velcro. Absolutely. Always going through it. Good
you
stuff,
can do
Mike.
Anything. It holds your pants up if you need it.
Well, yeah. Yeah, I suppose it would.
You make a belt out of it.
Yeah.
This is good stuff.
Okay.
I love it. It's like bubble wrap. You just can't get away from it.
Yeah, yeah. The bubbles, yeah. Pulling the Velcro apart.
Yeah, just pull Velcro apart.
Mr. Paul, how about
Okay.
Rosanna's fun facts?
Fun facts. All right. Let me see if I can find the button to share the screen. This helps, I guess. And there we go.
Rosanna's Fun Fact.
Well, now, welcome back, Rosanna, for another wonderful Rosanna Fun Fact. And in keeping with our discussion on the James Webb Telescope, Rosanna's got some really cool facts about that. So let's get right into it. So, what an exciting week this was with the unveiling of the first ever images of the James Webb Telescope. I was watching on Tuesday. I was disappointed to see that the Canadian YouTube link failed when it was our turn to participate in the exciting moment. The link has since been fixed and reestablished, but in case anyone had missed it, I thought it would be I would delve into the Canadian Space Agency's part in the James Webb adventure. Now, Canada actually has an amazing part in the creation of the James Webb Telescope, and by participating in this international collaboration with NASA and the European Space Agency, the CSA is guaranteed access to 3 programs. One being early release science, second being guaranteed time observations, and also general observations. So Canadian astronomer Dr. Els Peters from Western University will be among the first to do science with the Webb, and she will be leading one of 13 chosen early release science or ERS programs. Dr. Peters and her team will study the interaction between infrared light produced by the very massive stars and their surrounding environment and seek to understand how far ultraviolet light affects the material between stars called the interstellar medium. Now, the Webb telescope can see through and beyond stellar dust, like the dust picture below from the Orion Nebula. Now, one of the 2 items Canadian scientists provided was a fine guidance sensor. Now, this is really cool stuff. I'm going to make that bigger. There we go. Now, the fine guidance sensor, let's turn this down, is beyond amazing. The FGS, fine guidance system, remains active during all of the telescope's observations, providing the stability system with extremely precise data 16 times per second. The Canadian-made by Honeywell sensor is so sensitive that it can detect a tiny angular displacement equivalent to the thickness of a human hair as seen from 1 kilometer away. Now that would be like spotting someone, that would be like spotting someone blink in Toronto all the way from Montreal. That's how sensitive that is. The other item is the NIRIS, also built by Honeywell. Now, this NIRIS stands for the Near Infrared Imager and Slit Spectrograph, a scientific instrument that helps study many astronomical objects from exoplanets to distant galaxies. Now, we have over 403 hours of guaranteed time observations. I'm just going to get this down here. Divided between 2 teams, the NIRIS exploration of the atmospheric diversity of transiting exoplanets, which is neat, led by Dr. Dave Lafreniere. I hope I pronounced his name correctly. From the University of Montreal. He will study the atmospheres of exoplanets, including their composition and temperature. Some of the NEAT program targets are rocky planets like Earth. The NEAT team hopes to make the very first detection of an atmosphere on such a planet. And Canadian NIRIS Unibias Cluster Survey, that's a mouthful, with the catchy acronym CANUCUS, led by Dr. Chris Willett. Now, from the National Research Council of Canada's Hertzberg Astronomy and Astrophysics Research Center, will study some of the first galaxies ever formed and galaxies found in groups called clusters. They will use the Canadian Nearest instrument to collect images and spectra from those galaxies at different periods of the universe's history. Probably everyone now has already seen the chart from the first Webb Nearest spectra. That part of that word. The spectroscopy data showing the steamy atmosphere of the exoplanet WASP 96b. The exoplanet is approximately 1,150 light years away from us. So this data that you're seeing here is basically they're looking at how much water that you're seeing on there, and then how much parts per million. And this is all basically based on certain wavelengths of light that they're able to collect this data. As Dr. Gallagher and Dr. Ouellette put it, this is the most detailed spectrograph on the exoplanet's atmosphere ever collected. That's these two gals right here. So Dr. Sarah Gallagher on the right is a science advisor to the president of the CSA, and Dr. Natalie Ouellette is the Canadian Webb outreach scientist and coordinator at the Institute for Research on Exoplanets at the University of Montreal. This is just the beginning of what the NEAREST, FGS, and the James Webb Telescope can do. In a world that is still dealing with the pandemic, wonky communications, and strange shortages, would someone please tell me where on earth is all the Excel peppermint gum? This is a hopeful, exciting stuff. Bravo, Canada. And let me just get that down there. And I'll try to do this. And that is this week's.
Rosanna's Fun Fact.
Hey,
That's
nice.
awesome.
Now that is interesting information, I must say. I didn't know Canada had that kind of input into the telescope, and how important it is.
Yeah.
You know how important it is, but that solidifies the Canadians' use of that scope for the things that it needs. Because apparently, you have to bid, not financially, but everybody has to apply for the time on this telescope for different things, because obviously it means different. There's different things it'll do for different people, and so to be unbiased about it, it's a blind trial, or not trial, but how do you say it?
Selection.
Competition
Okay.
for who gets what for time on this thing. So anyway, it's really cool stuff.
Well, it's great that Canada took part in that. That's it's in with the Gateway project that NASA's bringing up the Lunar Gateway for the space station going around the moon too. Canada's going to take initiative in that. We need to be in that part of the technology for sure.
Yeah.
And the spin-offs are just crazy for it. So awesome. Thank you, Rosanna, for that.
Yes.
Great information. Okay. I've got some photos to present, and then from there I've got some photos to present that came in for the contest that I was running, and I was asking people to send me a photo of our celestial neighbor, the moon, and I have a couple of prizes here to award. But first I'm going to get to the photos that we had submitted tonight, or that were submitted tonight to the channel. Just need to bring them up here. 1 second. And I'm going to share my screen so everybody can see them. Let's go here. And okay, photos. What we got? Okay, we're going to start off with this one from Bridget Green. And look at that. This isn't Split Rock, it's someplace else. She said, "Hi Chris, I spent 10 days tenting in Gaspé, Quebec with my best friend and saw amazing sunrises and sunsets. Now these are a few of them taken in Percé, P-E-R-C-E, Quebec, and Carleton, Quebec," she says.
Beautiful shot.
Yeah. Pretty spot. Looks like St. John's Beach.
Yeah, gorgeous.
Yeah.
Oh, look at that. Very nice.
That looks like that place down by Fairfield.
Yeah, it does. Awesome. Thank you, Bridget, for those. Glad you had a good trip. Sarah Second C sent this one in from the Full Moon Observers group page, he says. I'd like to share this pic. He took it, he said, Sunday 10th, 2022 at 3:15. He said, P.S. Love your page and keep up the good work. So nice
Wow.
Jupiter capture there. Awesome.
There you go.
Good
Nice.
stuff. There you go. You're on your way.
Absolutely.
And we have this one from Stuart Lyons. He says, Hi, Chris, Paul, and Mike. I really enjoy your show. Wanted to share with you a photo of the moon that was taken on the island of Saint Martin back on May 16th,
Oh,
2022
nice.
at
Wow.
6:53 a.m. in the morning. He says, at first glance, you would think it was the sun, but actually it's the moon. He said the resort I stayed at the Divi Little Bay Beach Resort sits on the southern part of the island facing the ocean. When I first woke up, I thought it was the sun, but I knew that was impossible, he said. Anyways, just want to share. Hope you all have a wonderful week. So thank you for that,
So cool.
Very
Yeah.
nice.
Stuart. Yeah,
Yeah.
we'll get pictures from away.
That's awesome.
See, they can see the moon in other parts of the world. Amazing.
Yeah.
Speaking of other parts of the world, here's Lisa. Hey, Lisa.
There we go.
Yay.
Lisa Fanning says, I went out Wednesday in hopes of getting a nice creative photo of the ISS. There were some clouds, which made for an interesting sky. As it passed directly overhead, I was able to capture it passing through the constellation of Draco. Yes, you did.
Yes, sir.
There's the head of Draco right there. She said, Rob commented that the clouds looked like a second dragon, so I realized I like how this one turned out. It does look like a
Pretty
second
cool.
dragon.
It does, yeah. It's fantastic.
As I said on my comment on your video, I was showing the ISS a little while back. I'm still processing that you and I were both looking at the same ISS flying overhead at the same time. You in New Brunswick and me in New Jersey.
Yeah.
Pretty cool. Yeah,
Yeah,
it is
that's
pretty
awesome.
cool.
Yeah.
I don't know if you can do that on a flat Earth. You have to be around Earth, I think, to do it. But anyway, an iPhone 13 10-second exposure at 9:58 p.m. Eastern Time on the 13th. Well done.
Awesome.
Thanks, Lisa. Got this one from Brad Perry. Brad says, Hi, Chris. He says, just sharing my capture of this week's full moon rise taken on the 13th in Fredericton. Awesome
Beautiful.
shot. Look at that.
Gorgeous shot.
Well done, Brad. Always great shots.
That was an incredible moon, too.
That was, yeah. Really nice. Thank you for that, Brad. Keep them coming. Stefan Picard sent this one there. Stefan's, he said, was so looking forward to shooting C2017 K2 Pan-STARRS, which is that comet right there, of course, as it was visiting Messier 10 on Friday night. And Messier 10 is a big globular cluster of stars. As you know, I love capture with 2 or more targets. Now, capture information, Canon T1i, piggybacked and guided on a Celestron Nexstar 6SE. Not bad, eh? For 6SE.
Not bad. You got it.
300 millimeter lens, a lens speed of f/5.6 and ISO 3200, 150 frames at 10 seconds each, stacked in Deep Sky Stacker, and processed in Photoshop and Lightroom. Awesome, Stefan. Thank you for that.
Nice work.
Nice work. Got these from Duckman Arsenal. He says the perigee moon, supermoon, the biggest, brightest, and closest moon to Earth in 2022.
Yes, sir.
Nice shot
I
there.
love the clouds, eh?
Mm,
Yeah.
Very nice.
Look at that. Beautiful.
well done. Thank you for those. Jason Dane sent in a photo tonight.
Wow.
This area, I'm going to have to get some explanation. Paul's probably going to know this one better, but he sent me this one to label it for me, so there we go.
There you go.
Cephas.
Cepheus, yeah.
Yeah. Very nice. Nice work, as always, from Jason.
Mm.
Beautiful shot. He's doing a lot of wide field stuff, and he does really, really good work that way.
Yeah.
Yeah. Incredible. Starfield.
Oh,
Yeah.
the stars just
Yeah,
endless.
There's only us. There's only us. Don't worry about it. There's only us. Yeah, sure. Bunch of crap. Yeah. That's not true. Yep. Family show. Okay. Thank you for those, Jason. And Jason sent this one actually from his capture from Comet K2 and M10. He took
And
last
M10,
night,
yeah.
he said. Yeah.
Beautiful.
Nicely done.
M10 itself is incredible.
Yeah, it's a nice
Yeah.
cluster.
But like I said, that comet's starting to show more detail on the tail. That's good.
He said, I wanted to shoot color, but it was just in the middle of some other projects, so just shot some luminance. Well, still turned out great. Thanks, Jason, for those.
Yeah, very nice.
Matthew Dupre sent this one in. Matthew says, my submission for the week, the Western Veil Nebula. This is about 45
Sure.
minutes of total exposure time with the Canon, with the Celestron 9 1/4 Edge HD with Hyperstar and Canon T3. Yeah,
It's got the Pickering's Triangle there too, eh?
That
Where
veil
is that,
never
Paul?
gets old.
Where's Pickering's Triangle?
Right down there. That's it.
Right there? Oh, there. Okay. Yeah.
There, yeah. He's got 2/3 of the Cygnus loop. Below that again, of course, would be the Eastern Veil and a little bit more nebulosity. And that would, if you could get a little wider to get the whole thing in. He's got 2/3 of it. It's a beautiful job.
Well, it's huge. That's the problem.
Yeah.
You really got to go wide field to get the whole thing in.
Yeah, amazing.
Oh, nice shot.
The birthplace of stars. The recycled stardust. That's what I call it.
That area never gets old.
Ian Bloom sent this one in. Greetings, guys, from Australia, where we have not been blessed with many clear nights, he says. Lots of rain and cloud cover. Sorry to hear about that, Ian. I did, however, manage to collect enough data to process this image of Barnard 68, a dark molecular cloud towards the southern end of Ophiuchus.
Yeah.
Ophiuchus.
Dark nebula. Gorgeous. So you can't just blocks out the stars completely.
Yeah, completely, yeah. It is around 500 light years away and super cold at minus 273 C. That is cold.
It's chilly.
In the lower central area of the image, the open star cluster NGC 6520 can be seen. The resultant image was achieved by stacking its equator and processed in raw therapy. Awesome. Thank you, Ian, for that.
Yeah, nice, yeah.
Great to get to see the skies from down under. All right, and if you have any photos, you can send them in.
Flip the picture over?
What's that?
Did you flip the picture over? Is that upside down?
I guess I should have, yeah. I should have. Oh, and Trudy, we want to put that photo in there of Trudy's.
That's
a
a really
gorgeous
just
shot.
That's
such
what
an
you showed
amazing
earlier.
shot, and it's such an amazing place
Yeah,
to
it is.
see those events out there.
Yeah.
Unbelievable.
Very nice.
Yeah.
Okay, there's a few questions here. Winston saying, is there a way we can work in stacked images for astrophotography in the future?
I don't understand that
I'm
question.
not sure. Is there a way we can work in stacked images for astrophotography in the future?
I'm not following. Like we do live stacking now, if that's kind of what he means, which means that you can actually observe live by taking images and just placing them on top like you would typically if you were stacking to complete a picture.
Right.
And you can do that in real time in front of you, and a lot of people do that. That's what they call electronically assisted observing.
Right.
And a lot of people are doing that now. So in fact, when we first started doing the show,
That's why we're here.
that's why we did it, was so that we could offer those kind of views, live views. But the advantage to that is you can actually see it in color, and you can see it almost like what you see behind me on this image here, which, by the way, is Pickering's Triangle.
There you go.
And the disadvantage was the fact we never get a clear Sunday night like right now.
That was the trouble. Anyway, so I hope it addresses that question if that's what the question was.
I'll check here. He also mentioned, Mike, he said, I made a portable battery for my telescope using your information from last week's stream. Thank you so much for the information. Works like a charm.
Awesome.
Here you go.
Here.
Hey. Yay. Stacking single photos, he said, to enhance the picture. Yeah, so we've talked about that, I think, a number of times, though, Paul, I think, about stacking.
Yeah.
So just send your picture to Paul, and he'll look after it for you.
Pictures.
That's what I do.
You got to stack them.
Yeah, pictures, that's right.
A one stack picture.
Okay, great for photos. Thank you so much for those. And if you want to send in yours, you can send them to SNAS at astronomybythebay.ca. We love getting them, and we love sharing them. So now let me go to what I had left, I guess, was the contest. So I had asked people to submit a photo of our celestial neighbor, and the two prizes I was giving away was this book by John Reed, or John's giving it away, I guess, Learn to Stargaze for Kids. It's an excellent stargazing book, not just for kids, but for everybody. There's the Andromeda Galaxy, all lit up there, talking all about it, the swan, the crab, a lot of things in here. Like it talks about the winter constellations, summer constellations, all seasons, the circumpolar objects, great information for anybody who wants to learn about the night sky, and it's very well written and very well illustrated too. So that's up for grabs. you'll be one of the first people to receive this book. It's just being published now, or just being released now. So this is one of the pre-release books. Also have this book by Nicole Martellero, which is the 2022 Night Sky Almanac by the Royal Astronomical Society of Canada. In this book, it does list, we get to look at the night sky, and we get to see what the month is going to be like, the events that are happening this month, that kind of thing. There's April's events, that kind of thing. So lists the phases of the moon, what dates, all that kind of stuff. Lots of information about northern lights, nice big full moon map to lay out, and so really good book, really well written, easy to read, easy to follow, and that's going to be the second prize. But first of all, we got to get to the pictures. So let me show you. Now, you guys, I'm not sure if you'll hear the video, but there is sound, and I know we've had trouble with Google Meets before trying to get sound to play on Google Meets, but I'll bring it up for the audience anyway, I guess. Not saying that you guys don't matter, but you know. You know. Okay. It probably won't play music, but we'll play it anyway. Here we go. I gotta share my screen. Let's go here, and we'll go here, and here. And I think I can bring it up here. So it's about 4 minutes long, so just bear with me. And I'll see where it pops up first of all. Hopefully it comes up in the right spot. No, it didn't. Let's bring it down to the right one. There.
Some nice shots.
Nice shots, huh?
A lot of
Yeah.
nice shots.
Yep.
Wish you guys could have heard that, but unfortunately, you can't. I guess something to do with meats, but we'll be off meats here shortly. So, anyway, lots of great photos. I mean, I only asked for, send me a photo, whatever, and I got lots. So your response is always awesome for these little mini contests that I run, and I love running mini contests because it gets us a chance to see how you all see the moon as well. We're all under the same moon is what I always like to say. So let's do a couple of draws here then for we'll do the first one for the 2022 Night Sky Almanac. Who wants to do the draw? Mike? Paul?
Yeah.
All right.
Well, here you go, Mike. Your hand's in there.
You got it?
For
Okay.
Yeah,
All right.
yeah.
Pass it back.
There you go.
Okay.
Thank you.
All right. There we go. All right.
There's something in that bowl other than paper.
So that's my snacks for later. Oh.
Yeah.
The 2022 Night Sky Almanac. Is that what I said? Or was it the Stargaze? No, it was the Night Sky Almanac, wasn't it? For
Yeah, I
Trudy
think so.
Allman.
There you go.
Hey.
All right, Trudy. Congratulations.
Congratulations, Trudy. Set that one aside. Okay, next one is for the Learn to Stargaze for Kids from Mr. John Reed. Thank you, John, again for those donations. Always appreciate donations to give away. So, yes, prizes, of course. Okay, next, Paul. I guess it's up to you, is it?
Okay.
All right, pass back. Okay, perfect. Thanks. Okay. That's a little stupid, I guess, isn't it? But really?
A little late now.
That's what we do.
Oh, hey, look who used this one. Roseanne Armstrong.
Hey!
Hey, Roseanne's Fun Facts. Yay! Good stuff.
That's fantastic.
Fantastic.
Awesome.
Fantastic. Okay, well, thanks, everybody. I'm going to... Wish I had another one. I don't. Sorry. I got this nice pen or this pair of scissors.
I have a paper clip.
Okay. Congratulations to both
Your own
Rosanna
entry.
and Trudy for their entries. Awesome to have them. And thank you,
That's
everybody,
great.
for entering the contest. Nice little mini contest, but it's nice to be able to run them every once in a while just to get us all back together again. And the idea is not, there's never any judging. As you can see, the entries all just go together. And the idea is that I know everybody has different levels of expertise and different levels of phones and the whole bit. It's not the idea of the quality photo. It's the fact that you're outside enjoying the moon while you're taking a picture. So it'll always be that way. It'll never be judged. My end, anyway. Okay. All right. So I guess that's about all we're going to cover for tonight, guys. Eh?
Yeah.
That's half past. That's good timing.
All right. All right. So then in closing tonight, we'd like to thank all of you again for your continued support. Also like to thank, of course, Rosanna once again. Congratulations, Rosanna. Yay.
Yay.
For another interesting Rosanna's Fun Fact segment. We also hope that all of you who have joined us from Rogers enjoyed the program tonight. If you would like more information about the wonders of the night sky, you can find me at astronomybythebay.ca. And thank you to all of our folks on YouTube, normally Facebook, but not tonight, and Instagram channels who continue to share our broadcast with your friends and family, such as the MB Stormer Weather Center, our friend Sean there, Trudy, and everybody else out there that plugs away at our program for us. Remember, we do love getting your photos as well, so send them into SNAS at astronomybythebay.ca, SNAS, and we'll be happy to include them on our next broadcast. Now, we are always looking for suggestions for topics for future shows. Send them in to us. We want to pass them back to you. Give us ideas that we can share back with you again. Because these guys can really put together a show really well, so I just leave it to them. Anyway, send them into astronomybythebay.ca, and we'll be happy to make that happen for you as well. And please let your friends and family know that we are here every Sunday night at 8 p.m. on YouTube and hopefully Facebook next week to edutain you on astronomy and the wonders of the night sky. So for now then, from Mike, Paul, and I, we wish you a very safe and happy week, everybody. Lots and lots of clear skies out there, hopefully. As we like to say, guys, open your eyes to view the skies and keep your scopes pointed up.
Yep.
Good night, everyone. Thanks for joining us.
Do, do,
Dun, 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 dun. Whew. Glad the music came up.